Welcome to the next session, my dear friends. So in the previous session we have discussed up to the question number 18 of the previous GATE examination questions. So we are continuing it from that. So question number 19. Next question is question number 19, GATE to 2017, 2 marks. GATE 2017, 2 marks from set 2. From set 2. Question number 19. Question number 19. A municipal corporation is required to treat 1000 meter cube per day of water. It is found that an overflow rate of 20 meter per day will produce a satisfactory removal of discrete suspended particles at a depth of 3 meter. The diameter in meters rounded to the nearest integer of a circular tank designed to remove these particles would be. So what is the given data? So here the rate of flow is given. So what is rate of flow? Rate of flow Q is equal to 1000 meter cube per day. 1000 meter cube per day, and overflow rate. Overflow rate V naught is equal to 20 meter per day. V naught is equal to 20 meter per day. Okay, now depth is given. So depth is h is equal to 3 meter. He is asking what? Dia of circular tank is how much? Okay, now what is the surface area here? So from here, from using these two, we can find the surface area. So surface area of circular settling tank A is equal to Q by V naught. So Q is 1000 meter cube per day and V naught is 20 meter per day. So here the surface area will be coming as 50 meter square. 50 meter square is surface area. Okay, and so if you want the surface area, so we need to have the surface area. If the surface area of a tank, okay, surface area of the tank is nothing but, if you look at the plan, of the tank is in a circular shape. Plan of the tank will be in circular shape. So here the plan area of tank is pi d square by 4. Plan area of the tank is pi d square by 4, which is equal to 50 meter square. 50 meter square. So now then equating these two, we will get the diameter value. That is equal to 7.978 rounded off to 8 meter. 7.978 is nearly equal to 8.0 meter. So this is the diameter of the circular sedimentation tank or circular settling tank. Okay. In the previous question also, I just by mistake I told volume. I have taken the volume equation and I have equated it in the previous question, question number 17. So actually a small correction in question number 17. See, in question number 17, in question number 17 also same question. Actually I just have to correct it. It was Q, it given as 1500 meter cube per day. Q was given as 1500 meter cube per day, and V naught was given as 20 meter per day. So here we got the surface area of each tank. We got surface area. we got surface area of each tank is 37.5 meter square. So there I told to equate it to volume, actually 0.785 H plus 0.0011 D, like that formula we have taken. It is wrong actually. We don't take here, it is volume. Okay, here it is surface area, right? So volume and surface area we have equated, that is wrong. So we have to equate this 37.5 meter square to surface area. Surface area means again pi d square by 4 only. Okay, this is correct. I have equated it to pi d square by 4 only. But here this is volume and this is surface area. We cannot equate them. So I told this one, it is wrong. Okay. So I have equated volume with this, which is wrong. We have to equate the surface area with the surface area. This is the surface area of the circular tank. Okay. If you got the volume, if this is the volume, then we need to equate it with the volume. That is the only thing we need to understand. Okay. Question number 20. Question number 20. GATE 2019 1 mark set 1. 2019 1 mark set 1. Question number 20. So here a completely mixed dilute suspension of sand particles having diameter 0.25, 0.35, 0.40, 0.45, 0.50 are filled in a transparent glass column diameter of 10 cm and height of 2.5 meter. The suspension is allowed to settle without any disturbance. It is observed that all the particles of diameter 0.35 mm settle to the bottom of the column in 30 seconds. For the same period of 30 seconds, the percentage removal, round off to the integer value of, okay. For the same period of 30 seconds, the percentage removal of the particles of diameters 0.45 and 0.5 mm from the suspension. See here, what is the given data? It is given that a water is having different sized sand particles. Okay, so the size of the sand particles in water, size of sand particles, they are starting from 0.25 up to 0.5, 0.25 and 0.3, 0.35, 0.40 and 0.45 and 0.5, 0.45 and 0.5. So these are the sizes of the sand particles present in the water. Okay. So it is in a sedimentation. It was taken on a transparent glass of 10 centimeter dia and height is 2.5 meter. It is not relevant for our question. The suspension is allowed to settle without any disturbance. Okay, let us take the height. Height is 2.5 meter and dia is 10 centimeter. Okay. It is observed that all the particles of diameter 0.35 mm settle. So here up to 0.35 it is settling. Up to 0.35 mm. Okay, up to 0.35 mm. It is observed all the particles of diameter 0.35 settle to the bottom in 30 seconds. So up to 0.35 mm. See, if 0.35 mm is completely settling, is completely if 0.35 mm dia particle is completely settling in 30 second, okay, in 30 second. Now for the same period 30 seconds, the percentage removal of 0.45 and 0.50. Simple. See, 0.35 is settling in 30 seconds. It is settling completely in 30 seconds. So what happens to 0.4, 0.5, 0.45, all these things? Obviously they will settle because it is lesser dia. If this lesser dia is able to settle in 30 seconds, why not the greater diameters will settle in 30? In fact, they will settle early than 30 seconds because of more diameter, more weight. So because of more weight, they will settle faster than 0.35. So the 0.35 is completely settling in 30 seconds. Then in 30 seconds, all these three will also 100% they will settle. So 100% they will settle. So here the answer is simply 100%. 0.45 and 0.5 mm percentage removal is 100%. Simple. Okay. So let us see the answer of 20. For 30 seconds. Yeah, it is 100%. Next question. Question number 21. It is a theoretical question. Question number 21. GATE 1997 1 mark. GATE 1997 1 mark question. So what is the question? Flocculation is a process. Flocculation is a process that removes algae from stabilization pond effluent. That is option A. So what is meant by flocculation? So flocculation. So let us first define from our side. What is flocculation? So flocculation, it is a process. It is a process of removing fine suspended and colloidal impurities. Fine suspended and colloidal impurities from the water with the help of coagulant. Okay, so this is nothing but flocculation. It is nothing but flocculation. Okay, so let us see what is the options given. Let us see what are the options that are given. What are the options given? The option B is that promotes to aggregation of small particles into larger particles to enhance their removal by gravity. Yes, it is a process of removing fine suspended and impurities by charge neutralization and agglomerization. Okay, by charge neutralization and agglomerization. This is two things which it will do. Okay, so agglomerization means increasing of size. Agglomerization means what? Increasing of size. So it will do increasing of size. And third one is that mixes the coagulant in water. See, flocculation is not mixing. Flocculation is preparation of the flock, subsequently preparation bringing the finer suspended particles together and increasing its size. So agglomerization is nothing but flocculation. Mixing is different. Mixing is different, that is rapid mixing will do. After rapid mixing, flocculation will occur. Okay, so this is not rapid mixing of coagulant in water. So the most suitable option is option B, that promotes to aggregation of small particles into larger particles to enhance their removal. That is the right choice. Okay, so question number 22, 1997, 1 mark. Question number 22. The question is like this: design parameters for rapid mixing unit are. So question number 22, the design parameters of rapid mixing unit. Design parameters. Design parameters of rapid design parameter. Generally, the design parameters of rapid mixing unit, I have told you. First one is G. So temporal mean velocity gradient. This is a very important design parameter, that is temporal mean velocity gradient. And next one is RPM. So how many rotations per minute that the shaft is making. So these two will decide the rapid mixing units design. Okay, so if you look at the options, velocity gradient and the volume of mixing basin. Okay, again this G is again calculated by using a empirical formula. Okay, an empirical formula depending upon the power. So G depends on power again. So what is the value of G? What is the value of G? G is equal to square root of P into mu by P by mu into V. P by mu into volume of the mixing basin. Okay, so here G is the prime design parameter. This G depends on power, mu and volume of the mixing basin. So design parameters for rapid mixing time depends on velocity gradient and the volume of mixing basin, and the option B is viscosity and velocity gradient, and option C viscosity, velocity gradient and the volume of the mixing basin also. So viscosity, velocity gradient and volume of the mixing basin also. So on all these three the design parameter will depend. Okay, so G depends on mu and V and also power of the shaft also. If it is given the power of the shaft also, the factor which will affect the gradient. Okay, so all the three is correct. It depends on velocity gradient G. Okay, it depends on velocity gradient and it depends on dynamic viscosity or simply viscosity, and also it depends on power and also on volume of mixing basin. And also if it is given P is also correct, power, and depending on that this RPM will vary, and also on RPM it will depend. So on all these factors the design parameters of rapid mixing unit will depend. Okay, let us go to the next question. Question number 23, 2004 GATE, 2 marks. 2004 GATE, 2 marks. 2004. See here, the design parameter for flocculation is given by a dimensionless number gt. Okay, so the design parameter of flocculation is given by a dimensional number gt. So generally gt is the design parameter, is the dimensionless design parameter of a flocculator, okay, of a flocculator. So this is the important design parameter of a flocculator. Okay, so what is g here? G is the velocity gradient, g is velocity gradient, and t is time of mixing. T is the detention time or time of mixing. Here it was given as detention time. So detention time. So V is velocity gradient and T is detention time. Values of GT ranging from 10 to the power of 4 to 10 to the power of 5 are commonly used, with T ranging from 10 to 30 minutes. The most preferred combination of G and T to produce smaller and denser flock. So here the thing is, we wanted to produce smaller and denser flocks. Okay, so smaller and denser flock means what I told already. When G is more, so G will decide the density of the flock. Size will be decided by the T. So G, if it is more, denser flock will form. If time is more, larger flock will form. So we want denser but smaller. So here we need to put large amount of G to have denser flock, and smaller means you are giving that denser, you are giving that larger G for smaller time. Then it will provide smaller but denser flock. So our combination is large G, small t. Excuse me. This is the combination required. Option A is the answer. Large G and small t. Okay. So likewise we need to find the value of this. So this is the answer, and your solutions, it was given as option D, but it is wrong. So this is the right answer. Larger G and smaller t is the right answer. Okay, so conceptually it is correct. Now let us go to the next question. Question number 24, 2005, 2 marks. 2005. Question number 24, 2005, 2 marks. So the question is like this. A circular primary clarifier processes an average flow of 5005 meter cube per day of municipal wastewater. The overflow rate is this much, 35 meter cube per meter square per day. The diameter of the clarifier should be. A very simple question given for 2 marks. 2005 and question number 24. So what is the given data? So given data is Q. Q was given as rate of flow, that is equal to 5005. Rate of flow 5005 meter cube per day. Okay, this is the rate of flow, and the overflow rate is given. Overflow rate it was given as 35 meter cube per meter square per day. Okay, so what is the dia of circular tank? What is the dia of circular tank? So first of all, surface area of tank is equal to A, which is equal to Q by V naught, which is equal to 5005 by 35. So 5005 in meter cube per day, and 35 is meter cube per meter square per day. So this will be in meter square finally. So 5005 by 35. So what is the value of it? It is equal to 143 meter square. It is equal to 143 meter square. Okay. So it is 143 meter square. Now pi d square by 4. So surface area means what? Surface area is equal to pi d square by 4, which is equal to 143 meter square. So here, from here we can find the diameter. If you do this, we will get the diameter in meter, which is equal to 13.5. Is equal to 13.5 meters. So this is the question number 24. So let us go to the next question, question number 25. Question number 25, GATE 2008, 2 marks. GATE 2008, 2 marks. GATE 2008, 2 marks, question number 25. Let us see the question. A water treatment plant is required to process 28,800 meter cube per day of raw water. The density of 1000 cubic kg per meter cube, kinematic viscosity 10 to the power of minus 6 meter square per second. The rapid mixing tank imparts a velocity gradient of 900 second inverse to blend 35 mg per liter of alum with the flow for a detention time of 2 minutes. The power input in watt required. The power input in watt required. So what is the given data? So the given data is the rate of flow is given. Okay, rate of flow Q is equal to 28,800 meter cube per day. 28,800 meter cube per day. Okay, and the density of the water is given 1000. Density of water is equal to 1000 kg per meter cube. Okay, and the kinematic viscosity nu. So kinematic viscosity nu is given as 10 to the power of minus 6 meter square per second. Nu is given as 10 to the power of minus 6 meter square per second. The rapid mixing imparts a velocity gradient. So velocity gradient G is given as 900 second inverse, okay, and alum doses is given as 35 mg per liter, and the detention time T is given as 2 minutes. Okay, so what he is asking now, the power input in watts. So what is the power in watts? Power in watts required is how much? Okay, so what is how to find power? So from the velocity gradient formula we can find power. So we know that G is equal to square root of P by mu into V. Okay, again in this formula we need to remember the units also. P should be substituted in watts. So P should be substituted in watts, and mu should be substituted in Newton second per meter square. It is should be submitted in Newton second per meter square, and this one in meter cube. Okay, we need to substitute that in meter cube. Then we will get G in second inverse. We will get G as second inverse. Okay, so now we know G. So G value is given here. Mu value is not given directly, nu was given. We need to convert this nu into mu. Okay, and one more thing is V, volume is also not directly given, so we need to determine the volume using the rate of flow and detention time. From there volume will come. So first let us find the dynamic viscosity. So dynamic viscosity mu, so here if we need to convert the kinematic viscosity into dynamic viscosity. So here nu is given in 10 to the power of minus 6 meter square per second. Okay, so mu is equal to rho into nu. So rho is how much? Rho is 1000 kg per meter cube into nu is 10 to the power of minus 6 meter square per second. Okay, so this is coming around 10 to the power of minus 3 kg per meter second. Okay, kg per meter second. So if I want to convert this into Newton, what I want to do, I need to multiply it with meter per second square. Okay, meter per second square. If I multiply it with meter per second square, so this is called Newton. Newton per meter second. Okay, Newton. So we want dynamic viscosity in Newton per meter square. Newton per meter square into second, right? So here we need to divide it with it. So if you divide it with second square per meter, then it will become second cancels, so Newton per meter square second. So dividing means what? So 1 by 9.81, 1 by 9.81, right? 1 by 9.81. So then it will become Newton meter square per second. So now I have converted this 1 by 9.81, approximately I will take it as 10. So then it is nothing but 10 to the power of minus 4. Okay, 10 to the power of minus 4 Newton per meter square second. Newton per meter square second. Okay. So this is value of mu. This is value of mu. Okay. This is the value of mu. Now here if I want to convert this, listen carefully. So if I am dividing it with minus 10 by 10, so I need to multiply it with it by 10 also. I cannot directly multiply and directly do this. I have to convert this into uniform units. Okay. So for that sake, I am again multiplying it with 10. It is getting complicated. Let us do it in another way. Let us do this in another way. See here, it is equal to 1000 10 to the power of minus 3 kg by meter second. Okay. So kg per meter second, it is nothing but, so if you convert this kg, so 1 kg per meter second is nothing but 1 Newton Newton second per meter square. 1 Newton second per meter square. So as I told you, if you are multiplying and dividing, then it will become 1 only. So here 1 kg per meter second is equal to 1 Newton second per meter square. Both are same. So both units are same. So I can convert this into 10 to the power of minus 3 Newton second per meter square. Okay. So both are same. So this is the value of mu in Newton second per meter square. The value of mu in Newton second per meter square. Okay. Now, so we got the value of mu. Now what we will do? We need to find the volume of the tank. So let us keep this aside. So mu is equal to 10 to the power of minus 3 Newton second per meter square. Mu is equal to 10 to the power of minus 3 Newton second per meter square. Now here volume. So volume of the tank. Volume is equal to, here the rate of discharge is given, volume. So generally rate of discharge Q is equal to volume by time. If you want volume, then Q into time. So detention time. Okay. Q into the detention time T. So volume is equal to Q into T. That means 28,800 meter cube per day. Convert this into minutes because T is in minutes. 24 into 60 meter cube per minute, multiplied with detention time 2 minutes. So that means minute cancel, it will come in meter cube. So it will come some value. So here G is equal to this. So G is equal to square root of P by mu into V. So P is equal to what? P is equal to G square into mu into volume. So G square is how much? 900 second inverse square mu What is the value of mu? 10 to the power of minus 3 Newton second per meter square. And volume, this one, 28,800 meter cube, 24 into 60. So second cancelled, meter cube and meter square and meter cube, meter 3 is cancelled, 1 meter is, so Newton meter. Okay, so we have got a Newton meter. Newton meter is nothing but it is power. Okay, it is power. Now sorry, here it will be second square, so second inverse into second inverse, so second inverse square, so 1 second inverse will left, that means meter, Newton meter per second. So Newton meter is work done, F into S, and by time T is nothing but power, rate of work done is power. So likewise unit wise it is correct, so just simply multiply it, you will get the answer. Because why I am stressing this much on units is, many of us know the many of us know the formulas and all, but many of us commit mistake in the conversion of units. So we need to be very much clear about units. Otherwise what happens, if you look at the options in this question, see, everybody will get the answer as 324 or 324 odd. We will get the answer. See, if you look at the answer, 32.4, 324, 324, 100. That means what? We will miss the units conversion. Here in this question, everybody will arrive the answer as 32.4 or 324 or 32400. But everybody will do some mistake in the conversion of the units. That is why I always stress on the units also. If it is, we are getting a power, then the power should be equal to Newton meter per second. That will come, that should come. Otherwise it is not power in watts. 1 watt is nothing but what? 1 watt is nothing but 1 Newton energy to move any particle for 1 meter in 1 second of time. Okay, per unit time. This is nothing but 1 watt. So that should be matched. Otherwise you are doing some mistake. Unnecessarily you will lose 2 marks. Okay. So that is very, very important. If you solve this, you will get answer of 32400 watts. 32400 watts is the answer. Okay. So that is the question number 25. So we will conclude this session and we will discuss the rest of the questions, 26 to up to the number of questions, 50 questions are there, I think so. So we will discuss all those questions in the coming sessions. Okay. Thank you so much.